In this recording, we discuss some other forces. We start with the normal force. What do we call the normal force? The normal force exists whenever two surfaces are in contact. Whenever two surfaces are going to be pushing against each other, we have a normal force. Your hand pushing against your hand is a normal force. Your hand pushing against the wall is a normal force. Whenever two surfaces are in contact, we are going to have a normal force. Now, it is always perpendicular to the contact surface. That's key. That's what the word normal comes from. The word normal means perpendicular. It is perpendicular to the contact surface. Now, one key point here, we are not going to have an easy equation for the normal force like we have for the gravitational force. The normal force is going to depend on what's going on in that particular situation. Its value is going to depend on the other forces acting on the object. We find it by adding all forces acting on the object and determine what's balanced and what's not balanced. I'll give you a quick example here. What if I have a floor and I have a mass on top of it? Now the floor is going to exert a normal force on the mass. Okay. We are talking of floor here, not the earth. We need to start building that distinction. That distinction is very important. The floor or top of a table if it is on a table, top of a bench if it is on a bench, that's what's exerting the normal force. It's not the earth. It's the surface. Now, this surface, this floor, is exerting F sub n on this particular mass. Now, F sub n is a measure of how much the floor pushes up against that mass. In the same token, thinking of the same situation, you see I'm drawing it distinctly because usually it's not a good idea to mix two different things. Even though I have the same situation, here I'm going to focus on what's going on the floor. Here I was focusing on the block. Here I'm going to focus on the floor. Now, is there a normal force acting on the floor? Absolutely. The normal force acting on the floor is going to look like this, pushing down on the floor. That's why when you stand on a carpeted floor, you leave an imprint of your feet on the floor. That's because your shoes, the bottom of your shoes, are exerting a normal force on the floor, are pushing down on it. That's what the normal force is. Okay, we'll discuss later on when we talk of Newton's third law of motion, how does this force relate to this force if there is any relationship, but that's what we are not, that's not the focus of this slide. Okay? Now, you see it's not pointing up here, the normal force acting on the floor. It is pointing down, pushing down on it. Here it is pushing up on the block. Here it is acting on the block. Here it is acting on the floor. Two different situations. Now, going back to the block situation, what if I stand on that block? Is the normal force going to be the same? And the idea here, no. It's not going to be the same because actually the block is going to push harder against the floor and the floor is going to push harder against the block. So suddenly when I stand on it, this normal force that the floor is exerting on the block is going to be larger. And actually, interestingly here, we have another normal force. And this is where you need to be careful and where you need to have a distinction. When you stand on a block like this, You are not exerting your weight on the block. That's a common misconception. What are you exerting? The soles of your shoes are exerting another normal force on the block. So let's call it Fn2. Okay? So do you exert the normal force because there is a gravitational force on you? Yes. But you should distinguish between both. The gravitational force acting on you is exerted by the earth on you. Do you exert a gravitational force on the block? Absolutely. You exert gravitational forces on every mass in the universe. But that force is too tiny, and we are going to ignore it. Now, the major force that you are going to exert on the block is through your shoes. The soles of your shoes, when you stand on it, the soles of your shoes, that's a surface that's in contact with the surface of the top of the block. There's going to be a normal force, and that's what you exert on the block. Of course, the block also exerts a normal force on you, but that's another story. If we are going to continue that way, we are going to stay on this slide forever. Okay. In summary, before I move on, the normal force, you are going to be able to determine it only by figuring out what other forces are acting on the object. Okay. The normal force is always perpendicular to the contact surface. It exists whenever we have two surfaces in contact. It has nothing to do with weight or anything like that. It has to do with whatever else is acting on the object, and we have to figure it out. Now, a couple of examples here. I took these pictures off the web. I just looked for pictures on the web and picked up these. And I can add another one where I have an object in free fall. Okay, now, for example, in this case, what we have is a block, another block, and they are tied through a string. And because of that string, both of them are going to be accelerated this way. Ignore all the numbers, don't worry about everything else. That's all what we are saying. But my focus here is just the normal force. On block 1, this bench is going to exert a normal force on that block. That normal force is going to point upwards. Now, this block here, the bench is going to exert a normal force on it. The normal force is perpendicular to the surface, so it's going to look like that. Perpendicular to the surface. So we have two different normal forces. In each case, the normal force is perpendicular to the surface, to the contact surface. That's what's important. Now, in this case, we have a situation where we are holding a sign through two ropes, two strings that are tied here, and we have another string that's tied to the sign. What's the normal force on the sign? Nothing. Why is it nothing? Because the sign, there is no surface of the sign that's touching any other surface. You need to have two surfaces in contact to have a normal force. We don't have one here. What about here? An object fallen. I wrote free fall here. I hope we should know by now, whenever an object is in free fall, the only force acting on it is the gravitational force. Notwithstanding, the question is there a normal force on an object that's fallen? Obviously no, since we don't have surfaces in contact. I take another case here. What about if I have a floor here, a wall here, and I put a ladder? What are the normal forces on the ladder? there is this floor here is going to exert an upward normal force on the ladder. This wall here is going to exert a normal force pointing this way, horizontal normal force on the ladder. What's key is perpendicular to the contact surface. That's what you have to focus on. Again, normal force, the word normal means perpendicular to the contact surface.